Hello, welcome back to BlenderSushi Live Noding. Still with the Spirograph explorations. I was trying the setup using Sverchok and I found that's quite difficult, so I decided to maybe simplify things a little bit. I'll use animation nodes for that. So instead of drawing all the circles using nodes, I'll try to use a manual kind of objects in the 3D scenes. So that's kind of make things a little bit simpler, I think. So I'll start with a circle here. So imagine spirograph, and we actually have like a kind of like a large circle like that, and then we have a small gear that's gonna rotate around, and we also have like a dots that we trace to generate the spirograph curve. So that's the plan. This is animation node spirograph. Okay. Now we have a bigger circle, and then we're gonna have a smaller circle. So this is just gonna be just for a visual kind of reference. It doesn't need to be circle. Really, for the spirograph, it's all about playing with the pivot, but having a circle makes things a little bit easier. So let's go to the top view. For the rotations, I will be using animation nodes, but for the positioning and the scaling, I will rely on Blender's own kind of attributes right here. So okay, this is a small circle, and that's a large circle. And let's go to animation nodes, and then turn off always, and just turn on this 3, and I'll use check transform output. Let's source the small circle and the large circle. You can actually do the parenting inside animation nodes. Let me have a look. Let me think. Parents, I think it's called parent. No, I think I'm just gonna do parenting over here. So imagine this guy is being parented to the big guy. So select this guy and select that guy, and Control P and parent the objects, and then we're gonna have like a point that we want to trace. So that's gonna be our point. And this we can parent it anywhere. For now, it's gonna be on top of this smaller circle. So that's gonna be the start of our tracing of the spirograph. So set parent to object, and then now we can start rotating the big guy. So we're gonna use the combine Euler. And rotation is going to be the z-axis. Plug in that guy to end frame. So the point is really to make things more simpler to understand rather than making things more complicated. So now, okay, the big circle is rotating, so the small circle should also be rotating at the same time. The speed, I don't know what's the number yet, it's just a trial and error. So Okay, rotate. We have this time. Sometimes the node become so small it's hard to select. Okay. Plug this into the transform output of that small circle. Now the smaller circle is now rotating as well. If you can see it, it's a bit maybe too slow or too fast. There's probably a math behind this kind of expression that's for gear. So when the smaller, let's say like for small circle to rotate around bigger circle, there must be a math so that the value is correct. But for what we are doing, we're really gonna use our eyes to do that. Okay, to trace the points, we gonna use particles and Sverchok. I could use animation nodes as well, but I think it's a little bit faster with Sverchok, at least at the moment. So, okay, rotations is good. Now we are gonna select the point. This is gonna emit some particle. Let's set it for 2000 points, 2000 frames. This is 2000. For every point, it's gonna emit a single particle. Turn on. Let's turn off the normal speed and then turn off the gravity. Now everything should be correct. One thing is with this setup is that we are using particle simulations. Normally, I rather have like a proper node setup, but we will see. Okay. At the moment, we are getting just an ellipse, so that's not what we want. We probably want to play around with the number here. So let's try it. Getting almost like just circular. But this is starting to look like the spirograph. Maybe I should make this a lot faster. Reset simulation. Probably too fast. Now we are starting to get something interesting. Okay, this is apparently making that kind of design. Because this is particle simulations, we cannot speed up the frame number. It's just gonna play back. We're just gonna wait until it's done. Ideally, I think we should get like the perfect kind of like a flower, the spirograph kind of flower. With the particles points being emitted, of course we can trace the particles and we get like a curve. So that's the final result that we want. Looks like it's gonna, this one's gonna just keep going. Let's see. We can make adjustment. Let's make this guy a little bit smaller, for example, and put it outside. That's still gonna work. Let me try something. There's actually a way in the animation notes to kind of simulate point generations by using loop. But I don't think I'm gonna do that now. Just wanna keep things simple with this. Yeah, I think it started to look alright. Let's try another setup. This can be a little bit faster. I could also put the point somewhere else. So this point right here, I can put it outside of the circle. And then let's see, have a look. You should get something that's more intricate. So basically this is just a matter of placing the pivot. Okay, that's creating this kind of design. The speed doesn't... Oh, the speed does makes a lot of difference there. If it's too fast, the problem with this method is the particles will be too far apart. So let's try putting this guy near the larger circle and then test it. There. We might actually get something that looks like an impossible spirograph. Normally, this will not be possible with the normal spirograph because of the constraint, the limitations of the actual device itself. But yeah, it is starting to look quite interesting. This is something else. With the particle itself, we can go to Sverchok and use the particle alpha nodes, objects MK2. It's gonna crash. Yeah, that's always happened. I don't know why. But I think the developer is working on it. Don't know what's causing the crashing. Always namespace signal. Soon we're gonna get our blender back. Okay, file save as. The good thing is particle still there. So let's grab it. Sverchok objects in MK2 particles. Plug in the object in there. Particles. We need to select our particle emitter. Get selection. And just use the UV connection and viewer draw. Plug this guy in. Plug that guy. Edges. You can continue with the simulations. Yeah, this is. I think eventually the first and the last points will meet somewhere, and then we get this kind of design. There's an endless pattern that I wish we can kind of try. There must be like the perfect formula for this to happen, that we can just adjust the variables and then the number of points will adjust itself, etc. Yeah, I guess, but this is alright, pretty good. We can bake it and save it. This one is unfinished spirograph. So what's good about this is we can just change this guy, change the scaling. Okay, this is okay, slightly bigger. I kind of need to lock the Z on that guy and this guy, so I can control the circle anywhere in X and Y, but not in the Z. And just imagine this is a spirograph, and then the little guy, this is the particle emitter, also should be somewhere around here. This is like a proper spirograph if it's inside the circle inside the circles, and it's rotating around a bigger circle. So there you go, that's a Sverchok working and tracing the point position. That's looking good. This is looking quite ellipsy actually, but the final result may be, yeah, still the rounded spirograph. This is not bad. Can do it a little bit faster in 3D view. Cool. See, that's full speed. Okay, let's Alt A, stop this, back to compositing. Let's just bake this, place it somewhere else. They are very similar, very similar. Maybe because of the speed here. Maybe make this 3 and make this 8. Let's see what we get now. Perhaps we can actually track 2 different points at the same time. That could be more interesting. Of course, like I said, if you kind of you don't want to wait for that, you can just grab the keys from the YouTube video. I'll show you real quick. you go to the BlenderSushi channel, just get from the previous live noding. I show you that we can just use the gist. So this guy. Probably sometimes using formula is really the most elegant solutions. I don't know. I think using nodes can be also interesting. But of course, yeah, this gist always comes in handy. Just grab this line, okay? Just copy. And then let's go to Sverchok, new node. And then here we can just import from the gist. Oh, here, import. And we have the Spirograph thing. Turn off the other guy. This is the Spirograph formula. I don't know. Sometimes really, if we have the proper visualizations, it's kind of nicer than having just the formula. Although of course with the formula you get it a lot faster. Yeah, that's a Spirograph. It's a lot faster. Why you do the hard way? Because sometimes it's more fun doing it the hard way. You kind of get a better understanding of stuff. That's kind of for the scaling, right? See, this is the normal Spirograph. The points itself, I don't know how many, but sometimes you get to the point where it's okay, that's touching the last point is touching the first point and it looks good. That's when you stop. Okay, something like that. That's the perfect Spirograph. Really, this is probably what you want. It's a lot simpler. But if you want to kind of try to make it using animation nodes or Sverchoks, using particle tracing or just the nodes, you'll get something more interesting, you know. With Sverchok, really, I think we can just, you know, create like duplicates of circles and then grab a point, and then it should generally create curve like this. But I'm still kind of thinking how to do that. Still kind of discussing it with the Sverchok developers. Let's hide this. You can also use the pipe, like I said. And I can bake this guy, and this one is more solid. So that's just the outline. This is just the preview, and this is the final result. Now, coloring the Spirograph. I guess that's the next thing I will show you. Coloring is not something. It's not that easy actually. You can do it in many different ways. Sometimes you can also use the texture. That's a nice. If this guy is a curve, you can use the texture for that and use the procedurality of the Blender texture. With this guy, if I use cycles render, this we might need to use the vertex color. So back to Sverchok, create a new node 3, colorizing Spirograph. Let's see, viewer draw. Vertex color, new. Grab our object. This is SV 0.001. and then we're gonna colorize the face or the vertices. I guess face is better. I'm gonna give it a color. Test it first. Single color, red color, and then index, range, float. This is the index for the face. So let's have a look. Currently it's just black. We need to give it a material. Stop this. The vertex color we have it SV call. SV call. Maybe use emission instead of diffuse. We have some faces colored with red because we are colorizing this guy using the vertex color, and this is also kind of a little bit hard to see because we are really just colorizing the face one by one here. And we need to kind of repeat the color as well, I believe. So we have like 500 stops here. We need to repeat this guy 500 times. Integer. Say, let's try 300 first, and this should be like 300 repeat of a red color. This is red color, RGB 100. And hopefully this works. Yeah, this seems to work. 500 and continue 5000. Apparently there's a limit with the range float. Maybe it's kind of like a caution. 5000. Can I have 5000 here? There's a limit with that integer input somehow. But that's colorizing this 5000. How about 15,000? 15,000 face. It's nearly there. Yeah, like I said, it's not the most intuitive because we are colorizing using the vertices color. Let's try 10,000, and we don't want it. Maybe we don't want it just red. But if you want to have multiple color, let's see. List join. Let's try red and green. Wrap it or mix it. Level 2 or unwrap. Let's try 100. This is also a little bit tricky here with the color. If we use a random vector generator, for example, make like a 100 color, plug this guy in, so we have random color. Here of course we can repeat the color a couple of times. That's also slightly difficult. I think list repeater and list join, that's what we need. Yeah, I think if this is like, if this is 2000, that's the number of phase index we're providing. 2000, let's see. If this is 1000 and then we have 5 here, we have 5000 phase color. Okay, that's a normal random color for each phases actually. So that's a, I don't know, I think colorizing phase using vertex color is a little bit tricky, but you have full control of it. Don't get me wrong. The easier way is just maybe just using a procedural texture in cycles. However, if you want to have like a color that goes from one to the next, it's a, yeah, it's not too easy in this case. But let's try one more thing instead of, let's not to give up. Let's try the vector interpolation, MK3. Let's have a look. If we have two color like this guy, red and green, and then we join it together, and supposedly there's like a transition happening here. Let me do this real quick. Float range between 0 and 1, and then we'll say 100 here, plug it here, and let's check it out, the result. In this case, a name like vertices doesn't really matter. This is just like the value between red and green kind of interpolating. So this maybe we can use. So you can see this is red into green. Okay, next. Maybe we want to do it over 10,000. This is really weird. With the integer, I cannot go over 1000. I think they need to fix that. I think there's a limit on this number. Maybe it's in here. Don't use a limit. Oh, minimum, maximum. Okay. Maximum 20,000. Okay, this is the link. This is something that we can set up. Okay, that's much better. So plug this into the stop and plug this into the interpolation count. Okay, that's much better. That's how we can interpolate color, red to green. In Sverchok, working with color is not the most intuitive. You kind of have it on your head like that, but you can still work on it. Imagine this is XYZ. It's an RGB value. You can easily add more like this. See, that's kind of starting to get somewhere. And let's add another color. If we are using HSV, I rather use HSV actually. RGB is a little bit difficult, but some people likes the RGB as well. RGB give you kind of color that it has certain quality about it. And this can be any number. Just give it a random number. Now we start to get somewhere. It's this is starting to get more interesting. I just put in 15,000 there. How many points do we actually have on this guy? Let me stop it. How many points? 15,796. This is the face of this guy. Looks like it's still pretty fast, so there's no problem. And let Sverchok interpolate all these numbers. Let it crunch all these numbers, and you don't need to worry. It's just gonna update it accordingly. So this is the cool thing about, again, procedurality. I like working like this. This is so fun. Once you get the setup, this should be like a kind of almost like a playing games and try to get a nice color. Currently it's interpolating amongst this random color, and this is what you get. One more thing you can do is, instead of using the vector interpolations, is to use the random number, I think, random number generator. So this can be interesting. It doesn't give HSV, unfortunately, but still. Okay, let's say the size is 1000 and just plug the value. This is actually, okay, this is, be careful, this is actually a float. We need to have vector in here. Just plug in there. We have red, random red color. Now it's become purple. Now it's become grayscale because we have the same seed number. Randomize the seed, and we have random color. It's a lot nicer like this. And the size, actually, we just plug in that guy. And this guy, red and blue. We have random color, and we can control it. Okay, you want it to be less, more red, less of blue. Yeah, that's nice, warmish kind of random color. See how it's coloring just the face. I think Linus was working on this node at some point, the vertex color neo. Thanks to him, we can have this nice set vertex color. We can play around with the seed. It's gonna generate different color. Oops, apparently I forgot to do something here with the seed of this guy. Here we go. You can have a higher number. Oh, that's too green. Maybe less green as well. It's too red. More blue. Yeah, nice purple. Maybe pinkish. Randomize the seed. Yeah, but random is pretty random. Sometimes you also want to have like a, you provide like a bunch of color and you want to color it accordingly. Yeah, there's a lot of patterns, list patterns that we can use to colorize things like Spirograph. I'm also still kind of getting used to it. It's definitely not simple things to do, because we are kind of like blank here. You're just working with pattern. Okay, list of numbers, and we have like over 15,000 faces. Normally, if you're doing the color on this kind of thing, you don't think too much about numbers. But in here, in this case, we do need to think about the color. See, index and color. So face index, imagine this is a slot and we have 15,000 of these, and for each color you kind of need, okay, to make a pattern, You can make it like a black and white pattern, but it's also, remember, this is working on a face, not working on a certain face loop, or I don't know. It's not simple, but definitely something that's can be fun to study. Maybe in the next one it will be easier. In the next live noding, I might still talk about the spirograph thing because it's kind of fun. It's much easier actually to think of color if it's a dots. So instead of this 15,000 faces, it's kind of like, wow, it's a big number. We can perhaps colorize it using dynamic paint and bunch of points. That's my next plan. Okay, so thanks again for tuning in to the BlenderSushi live noding. Leave comments and feedbacks down below. If you have any ideas, just let me know. Yeah.